If you know that at least one of A or B is true, and then you discover that A isn't true, then you can conclude that B is true. Likewise, if being assured that at least one of A or B is true, you discover that B isn't true, then you can conclude that A must be true. That form of reasoning, where you start out with two possibilities, eliminate one of them, and so conclude that the remaining option must hold, is known as disjunctive syllogism. The ancient Greek logician Chrysippus apparently argued that even animals, like dogs, engage in this kind of reasoning. Sextus Empiricus, another ancient Greek philosopher living a few hundred years after Chrysippus, reported that according to Chrysippus, and here I'm quoting Sextus Empiricus describing the views of Chrysippus, the dog uses repeated application of the fifth undemonstrated argument schema when, arriving at a juncture of three paths, after sniffing at the two down which the quarry did not go, he rushes off on the third without stopping to sniff. For, says this ancient authority, the dog in effect reasons as follows. The animal either went this way, or that way, or the other. He didn't go this way, and he didn't go that, therefore he went the other. Some natural deduction proof systems include a rule specifically for disjunctive syllogism. So those systems have a rule that says, given a disjunction and a negation of one disjunct, you can derive the other. However, we won't be incorporating a rule like that into our system. So in order to show that an inference like Q or R, not R, therefore Q, is valid using our proof system, you can't just complete the proof in one step like you could if you had a rule specifically for disjunctive syllogism. How then does one show within our proof system that that inference is valid? We use the disjunction elimination rule. We show that both of the disjuncts, Q and R, lead to the conclusion Q, which will then allow us to derive Q. Showing that the first disjunct Q leads to the conclusion Q is, of course, trivial. We just used the iteration rule to derive Q from Q, and we're done. What about showing that the second disjunct R leads to the conclusion Q? Here, in order to derive Q, we have to rely on the fact that the second disjunct R and the second premise, not R, contradict each other. So when we suppose that R is true, we get a contradiction, we get absurdity. And from absurdity, we can derive anything. And so in particular, we can derive Q. One way to derive Q once you have absurdity would be to temporarily suppose not Q, then use the iteration rule to derive absurdity under that supposition, which would get you not Q, which gets you Q. But the fastest way to derive Q from absurdity in our proof system is just to use the ex falso quod libet, or EFQ rule, which allows you to derive anything you want from absurdity in a single step. Now that we've derived Q from both the first disjunct Q and the second disjunct R, we're allowed to conclude that Q must be true. It admittedly seems a bit strange to show that the inference Q or R, not R, therefore Q, is valid in this way. That seems like such a simple inference, as Chrysippus argues. Even dogs seem to engage in that sort of reasoning. Whereas the proof that it's valid within our system is strangely complicated, since it relies on the idea that from absurdity anything follows. However, there are benefits to keeping the rules in your proof system to a minimum, so that's why we won't incorporate a rule specifically for disjunctive syllogism, and will instead show that that form of reasoning is valid in the way I just demonstrated.